Hello friends, welcome back to my channel Chemistry with TV. In this video, we are going to learn as to how do we find out the composition of a mixture of ethanoic acid and sodium ethanedioate by doing a titration. So here is our question. We have got 1.9 grams of this mixture which we have made up to 250 centimeters cube of solution. Now we are carrying out two titrations here. First titration is for the sodium ethanedioate, basically for the C2O4 2 minus ions. So these C2O4 2 minus ions, when I am titrating these with manganate ions, then manganate ions are going to oxidize the C2O4 2 minus to carbon dioxide. Ratio in which these two are reacting is 2 to 5. So first of all, let's find out what is the amount of C2O4 2 minus ion. So for doing this, we are going to find out the number of moles of manganate ions by using the volume and the concentration. So when we use 0.02 times 26.50 over 1000, so we get 5.3 times 10 to power minus 4 moles of manganate ions. Applying the ratio of 2 to 5, we are going to get the number of moles of C2O4 2 minus by doing divide by 2 and times by 5. So when we do that, we are going to get 1.325 times 10 to power minus 3 moles of C2O4 2 minus ions. Now mind you that these were in 25 centimeters cube of solution, whereas originally we had 250. So therefore, if this is in 25, then in 250, the amount of C2O4 2 minus ion is going to be 10 times, or 1.325 times 10 to power minus 2 moles. Now remember that these C2O4 2 minus ions are coming from ethanedioate ions, which is a salt, as well as from the dissociation of ethanedioic acid, because ethanedioic acid, when it reacts with hydroxide ions, that also gives you C2O4 2 minus, but even otherwise it is an acid, and therefore it's going to dissociate into its respective ions H plus and C2O4 2 minus. So therefore these C2O4 2 minus ions are going to come not only from sodium ethanedioate but also from the ethanedioic acid. So now let's see how much of ethanedioic acid was present. So in order to do that, now again we will do from the second, we'll going to use the data from the second titration. So the number of moles of H2C2O4 we can again find out using this concentration and the titer volume, which is 10.45. So 0.1 times 10.45 divided by 1000, so that gives us 1.045 times 10 to power minus 3 moles. Now mind you, this was hydroxide ions, but the ratio in which the hydroxide ions and ethanedioic acid reacted, that was 1 to 1. So therefore the number of H2C2O4, this is in 25, so therefore in 250 it would be 10 times, or 1.045 times 10 to power minus 2 moles. Now ratio of ethanedioic acid and ethanedioate ions that will be generated is 1 to 1. So therefore the number of moles of C2O4 2 minus ions here that came just from the ethanedioic acid, that is also the same as this. Now let's see what do we need to do further. Now you can see that the number of moles of C2O4 2 minus ions, what we found out from the first titration, that was 1.325 times 10 to power minus 2 moles. That was the total ethanedioate ions. So, and some of these had come from the ethanedioic acid. How much? This much, 1.045 times 10 to power minus 2. Okay, so these are from the total C2O4 2 minus, and these have come from the H2C2O4. So now when we subtract these two, then we get 0.28 moles of ethanedioate ions were there. So all of these now. So that means the number of moles of Na2 sodium ethanedioate is 0.28 moles. Now we know that the MR of Na2C2O4 is 134, we can find out, and therefore the mass is moles times MR. So we'll multiply the moles 0.28 by the MR, which is 134, and we arrive at 0.3752 grams. So this many grams of ethanedioate ions or Na2C2O4 are present. So percentage by mass, because the original mass that we had started with 1.9 grams, so therefore it will be 0.3752 over 1.9 times 100. So that gives us an answer of 19.7%. That was the percentage of ethanedioate ion, sodium ethanedioate. So I hope this explanation was useful for you, and if you like this video, please like, share and subscribe. Thanks for watching, and I look forward to see you in my next video. Bye. Take care.